For more than half a century, no human has traveled beyond low Earth orbit. No one has seen Earth shrink into a fragile blue sphere while heading for another world. That era is about to end. Inside a vast concrete cathedral in Florida, a rocket taller than the Statue of Liberty stands fully assembled. At its peak sits a spacecraft designed not just to visit the moon, but to take humanity beyond it. This is NASA's Artemis II mission. The first crewed flight of the Artemis program, the first time humans will leave Earth orbit since Apollo 17 in 1972. And right now, the final steps are underway. At the center of this mission is the Space Launch System, or SLS, the most powerful rocket ever built. Standing inside the Vehicle Assembly Building at Kennedy Space Center, SLS towers over everything around it. Its core stage alone holds more propellant than the Saturn V, and its boosters deliver raw thrust unmatched by any operational rocket on Earth. On top sits Orion, a deep space spacecraft designed to keep astronauts alive far from Earth through radiation, isolation, and extreme temperature swings. Together, they form the backbone of Artemis II. This is not a test of engines anymore. This is a test of human spaceflight beyond Earth orbit. When Artemis II launches, 4 astronauts will be on board, 3 from NASA and 1 from Canada. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen. This mission is historic in multiple ways. It will be the first crewed Artemis flight, the first time a Canadian astronaut travels beyond Earth orbit, and the first time Orion flies with humans on board. But before any of that happens, the rocket must leave the building. The next major milestone is rollout. NASA plans to move the fully stacked SLS and Orion from the Vehicle Assembly Building to Launch Pad 39B, the same legendary pad used by Apollo and the Space Shuttle. The journey is only 4 miles, but it can take up to 12 hours. The rocket rides atop Crawler Transporter 2, moving slower than walking speed. Every vibration, every shift, every gust of wind matters. If weather conditions or technical concerns arise, rollout stops. There are no shortcuts. This is the moment the mission becomes real, when flight hardware leaves the safety of the building and enters the open world. In recent weeks, engineers have found and fixed several issues. A cable in the flight termination system was bent outside specifications. A valve in Orion's hatch pressurization system needed replacement. Ground support hardware used for breathing air showed leaks. To the outside world, these sound like problems. To engineers, this is exactly what final testing is for. Every fix now is a failure prevented later, when lives are on board. NASA's philosophy is clear. Crew safety overrides schedules. Once at the pad, work accelerates. Electrical systems are connected. Environmental control ducts are attached. Cryogenic fuel lines are prepared. For the first time, the entire integrated system, rocket, spacecraft, mobile launcher, and ground infrastructure, is powered on together. This is where hidden problems reveal themselves. Afterward, the Artemis II astronauts will perform a final walk down at the pad. They will inspect the rocket that will carry them farther from Earth than any human in over 50 years. Then comes one of the most critical tests of all, the wet dress rehearsal. More than 700,000 gallons of cryogenic propellants are loaded into the rocket. Liquid hydrogen and liquid oxygen, colder than -200 degrees Celsius. Teams practice the entire countdown. They hold, resume, recycle, abort, recover. This is where Artemis III taught hard lessons, especially with hydrogen leaks. Artemis II procedures now incorporate those lessons, refined, tightened, and monitored with extreme caution. If anything goes wrong, the countdown stops, and if needed, the rocket rolls back to the assembly building. No launch date is worth risking a crew. Launching to the moon is not as simple as waiting for good weather. Earth rotates, the moon orbits Earth. The spacecraft must align perfectly with both. Artemis X has additional constraints. Orion must enter high Earth orbit first to test life support systems. The trans-lunar injection burn must place the spacecraft on a free return trajectory. Orion cannot remain in darkness for more than 90 minutes at a time. The return path must allow safe atmospheric re-entry. These constraints create narrow launch windows, roughly 1 week of opportunity followed by 3 weeks of no-go. This is orbital choreography at its most unforgiving. Apollo proved humans could reach the moon. Artemis must prove they can stay. Artemis II is not a landing mission. It is a systems mission. It validates life support, navigation, communications, heat shields, and crew operations far from Earth, all of which are required for Artemis III, lunar surface missions, and eventually Mars. This is the bridge between flags and footprints, and a sustained human presence beyond Earth. In the coming months, one rocket will roll slowly toward a launch pad in Florida. But symbolically, humanity will be moving much farther. Back beyond Earth orbit, back to the moon, back into deep space. Artemis II is not about nostalgia. It's about momentum. If you want to follow humanity's next giant leap, like, subscribe, and join us here on Skyward Space Quest, where we track the missions shaping our future among the stars. The countdown has begun.